28th, modern physics, another occurrence from photoelectric effect, and the level of the question is also straightforward. Light is incident normally on a completely absorbing surface with an energy flux or the intensity, that's the same thing, power per unit area. And the surface has an area of this much. So what I can do is that this is intensity, this is area. I can calculate the power, which is I multiplied by A, the intensity multiplied by the cross-sectional area, right? The momentum transferred to the surface in 40-minute time, let's see. That means in that given time, how much energy would be transferred? Let's try to see in that way. Because this is the energy of the photon that arrives in this given time, and the whole energy of the photon would be transferred to the surface because of the fact the surface is absorbing, right? Now, once you get this much, you know the expression E would be equals to P times C, where small p has been reserved for momentum. The earlier one was the power, right? So now you can easily calculate the momentum which has been transferred. A bit of calculation in exponent may require, but that will easily give you option number 3 as the correct one. All right, now we have the last two, the 29th and the 30th. All right, question number 29, moment of inertia. A bit of geometrical variation has been given. A solid sphere of mass m, radius r, is divided into two parts. The first 7m by 8 and the second m by 8. And the first 7m by 8 has been converted into a disk of radius 2r. Okay, so let's try to say in this way. A bit of variation as I've already said. So let's see. Here is a sphere. Let me not go with exact scaling. And the total mass is m. And we are dividing it into two unequal parts, the 7m by 8 and m by 8. And this 7m by 8 part, the first one, has been converted into a disk of radius 2r. Okay, so here the 7m by 8, the mass, and it has been converted into a radius of 2r. That means the changes are made in the thickness part so that, you see, the radius would be 2r. That's not a problem. You can make changes in the thickness part of the disk. And remember, r is the radius of the original sphere. So here the radius is r. And what it says is that I1 is the moment of inertia of the first arrangement. And for the second case, this m by 8 has been converted into a sphere. That's been given there. And the radius has not been given. Of course, that can be easily calculated. And I think we can do it because if m has radius r, m by 8 will have a radius half because, you know, ultimately volumetric distribution is there. So radius half means volume is 1/8. Consequently, mass is 1/8. And we need to calculate the moment of inertia about this, and this has been called as I2. And effectively what has been asked, I need to calculate the ratio of I1 by I2. So I consider this question to be more like a data handling where presence of mind is required. During the process, things should not be skipped. And that's a very important thing one needs to have in examination, the presence of mind. That's very, very important. Let's say the first case I1 is going to be 7m by 8 into 2r square by 2, right? mr square by 2. And for the case of the solid sphere, I2 is going to be 2 by 5, mass is m by 8, the radius is r by 2 whole square. That's all. So one is I1, other is I2. The question wanted the division. You do it. I1 divided by I2. When you do that, you get 140. So that means option number 1 is the correct option for this question, the 29th one. Now it's time we move to the final question, the 30th question. Okay, 30th from the dimensional part, and this is also a regular expectation because we get question from this, and it says in the formula x equals to 5yz square, x and z have the dimension of capacitance and magnetic field. Okay, and we need to calculate the dimension of y. I think that's straightforward, right? If I want to calculate the dimension of capacitance, then there are many different ways, and one of the easier ways, say, u equals to q square by 2c. So c would be q square by u, and q is a square t square. U is the energy, ml square t minus 2. That's how you go. We got the dimension of c. And what about the magnetic field? If I want to calculate the dimension of magnetic field, I can use this F equals to BIL. I think that will be easier. So B would be F upon IL, and F is MLT minus 2, and I is of course A. So you see F equals to BIL, and here comes the length. So this will give you the dimension of magnetic field. The dimension of magnetic field, the dimension of capacitance, you put it there, that's a straightforward one. Option number 4 would be the correct one. All right, so with this question, question number 30, we finish off the solution of this set of paper. That is the paper that had been put on 10th April 2019 evening shift. For those who came with this particular examination, I wish all the best and may you succeed in your life. And specifically for the future aspirants who are watching it, hope the solutions were quite handy, precise, so that you could get a wonderful idea and overview about this. All the suggestions, all the conclusions that we had made in the course of solution, those are very important and that will be very helpful for you to crack the examination. This is all from my side. Thanks for watching. Thank you very much.